Now, Newton's first law is a very special example because it only deals with a very special case where the forces are balanced. And what we're going to look at the end of this week's lessons and next week's is what happens then if the forces aren't balanced. So let's say we have a car, and there's some friction acting on it. So we have a backwards force of 200 newtons, but the forwards force is 300 newtons. Those forces aren't balanced. In fact, there is a resultant force of 100 newtons to the right in this case. What happens there? Well, Newton's first law doesn't apply. So it doesn't stay stationary if it was stationary, and it doesn't stay at the same speed in a straight line that it was doing beforehand. So what actually happens here is if there's a forwards force, it will cause the object to speed up. Now, or the speed to increase. Another word we have for that is accelerate. Okay, so the object will travel faster with time. If the force was backwards, so let's say in this case friction was bigger than the forwards force, then the resultant force would be backwards, and it is the resultant force that determines what happens. Then what that would do is it would cause the car to slow down or decelerate. Okay, now we're going to look at equations that link the resultant force and the acceleration next lesson, which is Newton's second law. But let's just look at what an acceleration is. Now, we can give this car a speed of, let's say, 10 meters per second. And what that means is every second it will cover a distance of 10 meters. So it'll cover 10 meters in the first second, another 10 in the next second, another 10 in the next second, if it was traveling at a constant speed. But let's say this has an acceleration of 5 meters per second squared. And this is how we write accelerations. It almost looks like the same unit as speed, but we have a little squared up here, and it actually makes the units completely different. This squared doesn't mean we have to square the 5 and make it into 25. It's just part of the units. Now, what this means is that the speed will increase, because that's what acceleration means, by 5 meters per second every second. So you can see we've got 2 seconds there, and that's why this is squared. So in this example, if the car was traveling at 10 meters per second and we have an acceleration of 5 meters per second squared, that means after 1 second, so when the time is 1 second after the start, it was doing 10 meters per second at the start, then its speed would have increased to 15 meters per second. And you can see that in 1 second, its speed increased by 5, and that's what the acceleration means. After another second, okay, so the time is 2 seconds, this is 1 second later, it increases by another 5. So the speed would then be 20 meters per second. So an acceleration just tells us how much the speed would increase by each second. Okay, so you can see this car is getting faster. However, we can have a deceleration. So if we have a deceleration, let's say we have another car, the resultant force is backwards in this case, and it was originally traveling at a speed of, let's make it 15 meters per second, and it has a deceleration of, let's stick with the 5 meters per second squared. Now we have a way of writing that in physics, which is it's an acceleration of -5. Okay, just means it's slowing down. Okay, so we don't use the letter D for deceleration because D is for distance. We use A, but we just make it a minus. Okay, and what this tells us is car's going forwards, it's traveling 15 meters per second. However, the acceleration is actually a deceleration. It's going to get slower with time, which means 1 second later, its speed will be 10 meters per second. Okay, so it's just going to slow it down by 5 each second. Another second after that, it'll have got 5 meters per second slower, so it will be at 5 meters per second. And then another second after that, it would actually bring it to a complete stop. Okay, so acceleration is really just a measure of how much a car's speed will increase or decrease in 1 second. Okay, if it's positive, if it's an acceleration, the object will get faster and the speed will increase each second. If it's negative, that means it's a deceleration and the car's speed will get less, it will slow down each second.